We can see your presentation now, so you can go ahead. Rengie? We cannot hear you. Rengie?
Give you an update of the air leakage database. The Max Sherman's group started this work many years ago. The database we have at Lawrence Berkeley National Lab is called the Residential Diagnostic Database. We've gone through many phases of this project. The latest effort is funded by Department of Energy and also California Energy Commission. Today I will talk about why we're doing this work, a progress update, and some ideas we have for future work if we were to get funded again. So project objective number 1, this work is funded partially by Department of Energy because they have an online tool called the Home Energy Saver. Home Energy Saver recommends energy saving updates based on some simple inputs by the homeowners. This online tool uses building characteristics to estimate air leakage of homes, and then it uses an energy model to predict the energy impacts of air infiltration. So to support Home Energy Saver, one objective of our database is to characterize the air leakage of U.S. homes. The other objective of this project is to support building codes revisions. In California, the building code is Title 24. The California Energy Commission has a research program that aims to reduce energy and peak power spent in homes to condition air that enters from the outdoor. So for this purpose, we want to recommend best practice for ventilations. So we collected air leakage data and analyzed the characteristics of new and existing homes in California. For our latest effort, we spent approximately 1 year to collect data from 130,000 homes. So right now in the database is approximately 200,000 homes. Not all the homes have sufficient data that we can use for the analysis. About 70 to 80% of the 20,000 homes have sufficient information that we included in our analysis. We store the data in a SQL database management system. We found this to be necessary to analyze and handle such a large volume of data and also allow multiple users to access it. In the past 4 months, we've been busy analyzing the data. So today I'll share with you a few slides on the summaries that we found. We are currently writing our reports, and in the future, there will also be an online tools where you can go and view some of the summary statistics from our database. So one question, these are some of the results from single-family detached home analysis. Some of the results I'm talking about here are similar to what we found before, but some of them are new. So in previous version of our database, we don't have a very good coverage of the whole U.S. So this time around, we specifically target areas of U.S. that we don't have sufficient information. So we now saw that there's a clear differences in leakages of homes from different climates. Warmer climates tend to have leakier homes in the U.S., and cooler climates in the U.S. tend to have homes with lower leakages. We found that leakages increases in floor area, and we used the metric normalized leakage. So this could be due to some artifact from our normalization. We also found that normalized leakage increases with height, and these are similar results than we found before. We found that houses built on a concrete slab is more airtight than homes within crawl space, perhaps not surprising there. We found that homes with ducts outside the conditioned space, which is still the common practice in existing U.S. homes, tend to have higher leakages. Income-qualified homes that participate in weatherization program tends to be more leaky before they're weatherized. On average, they're 50% as leaky than comparable homes. energy efficient homes are about 30% less leaky. So I'm going to show you two results that we weren't able to determine before, but now with the newer data sets, with more data, we're now able to tell. One is referring to the question that someone asked, how does air leakage changes as a home age? So really, there are two things happening here. We found that homes get leakier as they age, but the other thing is that we are building tighter homes now. So there are two factors that are happening, and we found that both matters. I'm showing here on this chart some predictions based on our analysis, for a medium-sized home or small-sized home, one-story home in California. So for those of you who are more familiar with air leakage at air exchange rate at 50 Pascal, so 0.6 normalized leakage is approximately ACH 50 of 10, and then 0.3 is about 5. So from our data, we found that aging is more, it explains why older homes are leakier, more so than our improvement in building tighter homes. The other thing that we're able to observe now is to look at how much retrofit reduce air leakage. We found that on average, the reduction is about 25%. The data sources that contribute to the data I'm showing you here includes low-income realization programs in the U.S. and also utility-sponsored energy efficiency programs. Some of the larger reduction that we saw came from realization programs because homes are leakier to start, so it's easier to fix up a leaky home than homes that are relatively tighter than to start. So these are the data that we weren't able to see before, but now with the data sets that we have, we are able to answer that. And this time around, we're also doing something different, which is instead of just looking at whole building envelope leakages, we also look at duct leakage measurements. So I'm showing here some preliminary results of duct leakage measured by duct blasters, CFM25, and plotted as a function of years. So we think it's important as we move forward to consider other types of diagnostic and look at it in conjunction with air leakage measurements. So other types of data that we hope to look at include combustion safety tests, indoor air quality measurements. If we are able to pull all these data in a database, then that will support more analysis. The other thing that we started to look at is multifamily homes. This is something that we haven't done so much in the past, but hopefully moving forward, we'll look at that. Remy asked us to think about the question why we need a structured air leakage database. So from our experience of collecting and analyzing this database over the years, there are many factors that affect air leakages. So in smaller, non-representative data sets, it becomes very difficult to identify how these different factors impact air leakages. So for this reason, you do want to collect consistently a large volume of data. Air leakage, as shown before, is important for calculating energy uses, and the aging effects, the geographical differences that I mentioned is it's really difficult to observe that in smaller data sets. In the past year, we did struggle, just like other speakers have spoken about, the different formats, level of details that data sources from different organizations will collect, and so having a unified format really helps. Unfortunately, in the U.S., building codes are under state jurisdictions, so it is difficult in our country to move forward with a unified format, although it is something that we like to push forward. So thank you very much. If there's any question, I guess I'll take after Andy speaks.
Okay, thank you very much, Rengie, for your very good presentation.